Remember, we've got a vertical one and also the positive one. I mean the vertical one and the horizontal one. So here we have, just have to solve that. It's x is equal to 1. The other one, y is equal to 2. This is our vertical asymptote, horizontal asymptote. And this is our horizontal. Right. For the domain and the range, you just oppose the asymptotes. For the domain and the range. Like here, our vertical asymptote, x is equal to 1. That's our vertical asymptote. You just solve for x on that denominator. X is equal to 1. So for the domain, you just oppose this. X must not be equal to 1, but x can be any value. X can be any value. X is an element of real numbers. Same thing here. You oppose this one. Y must not be equal to 2. But y can be any value. It mustn't be equal to 2, but can be any value. Y is an element of real numbers. Right, let's say, for instance, you are to write a vertical shift. A vertical shift. The vertical shift, remember, this is our y, plus something. So, which means plus 2. We are shifting. So, vertical shift is 2. Whereas, the horizontal shift is 1. It's a vertical shift, that's a horizontal shift. Right, now we are to find the equation for the axis of symmetry. Equations for the axis of symmetry. H at x is equal to a over x minus p plus q. Right. When we look here, we've got the one with a positive gradient and also that one for a negative gradient. Let us represent it using a graph. X, y. Right. Let's sketch this graph here. It's negative 2 over that. Right. The most important thing, if you are to sketch a hyperbolic function, number one, remember, it will reflect like that. It's on the third quadrant and first quadrant, or second quadrant and the fourth quadrant. Right. So if you are to sketch this, you need to find, number one, x and y intercept, and then you indicate the asymptotes. That's what is very much important. You can also put just 1 point for the graph. Here, we've got these asymptotes. These are our asymptotes. X is equal to 1. X is equal to 1. Indicate that line. X is equal to 1. Y is equal to 2. Y is equal to 2. Y is equal to 2. So when we look here, we have shifted our Cartesian plane. We shifted our Cartesian plane 1 unit to the right and 2 units up. That's why now we are having this. We are shifting the Cartesian plane. This is y, that is x. We are just shifting it from the origin, 1 unit to the right, 2 units up. That's why now we are having these coordinates here, which is 1:2. Our origin now is there, which means our graph will have x-intercept and y-intercept because it has shifted. If you are to put -1 in the place of x, it will be -1, -1. That will be +2. We are putting -1 in the place of x. It's -1, -1, which is -2. -2 divided by that, it's a +1 plus shift. It's plus shift. So we are adding the shift. It's +1 plus shift, that is 3, because the graph has shifted. Now, let's find the y-intercept. For y-intercept, we'll let x to be 0. If x is 0 there, this would be -2 divided by -2. -2 divided by -1, that is positive. It's +2 plus 2, that is 4. So now it is no longer undefined if x is equal to 0 because there is a shift. Right, let's continue. Put 1 in the place of that. 1 minus 1 is 0. -2 divided by 0, that's undefined. That's the reason why where x is equal to 1, the graph won't exist. That's why we are having that asymptote today. So let's find the y-intercept so that we are going to see where this graph will cut our y. Put 0 in the place of y. It will be 0 equals -2 over x minus 1 plus 3. We transpose to this side, it's -2 equals -2, right? We multiply by the denominator on both sides. It's -2 times x minus 1 is equal to -2. We solve that, it's -3x plus 2 equals -2. We transpose -2. When we transpose 2 to -2, it's -2x is equal to -4, and then we divide. Our x will be equal to +2. So we've got the y-intercept. Now we've got what we call the x-intercept, which means this graph will cut where x is equal to +2. And it will cut y. It will cut y where it is +3. Let's now look at the value of a. The value of a is negative, which means our graph is increasing. Therefore, it will be looking like that. Remember, we've got this asymptote, the vertical asymptote.
Y-intercept is 4.
Our y-intercept is 4. Therefore, that's how our graph will go. It goes like that. And also here, our x-intercept is positive 2. It goes like that. It doesn't touches the asymptote. It has shifted. After it has shifted, we are now having x and y-intercept. We are now having x and y-intercept. 0 is to 4, 0 is to 4, and then here we are having 2 is to 0. It doesn't touches the asymptote, right? When we look at our graph, if we are to divide it, it will cut here, this point here, this point. Our x here is 1. And then our y here is positive 2, which means this point is given by 1 is to positive 2. If we are to write the equations for both positive and a negative gradient, equations for both positive and negative gradient for the asymptotes, for the axis of symmetry, let's see. Remember that it's a straight line, therefore, it's y minus y1 equals m into x minus x1. y1 and x1 is the point of intersection for that. y1 and x1 is the point of intersection, therefore, remember, it has to pass there. It has to pass there to divide this into 2 equal half, or it goes like that. We do not know the x and y intercept for those lines. Let's see them. It's y minus. We are using the point of intersection only. Point of intersection, it's a P is to Q. P is to Q. Whereas, of which here we are having the value of P, we are having the value of Q. Therefore, our point of intersection is 1 is to 2. Right. It's y minus y1, which is 2, is equal to, remember, the only thing that we did here, we just shifted the, what we call our x-axis to that point. So the gradient, it's still 1 into x minus 1. Therefore, y minus 2 will be equal to x minus 1. We transpose, y will be equal to 2. We are transposing 2 plus x minus 1. And then we add the like terms. Therefore, our equation will be given by x plus 1. That's the equation for the axis of symmetry for a positive gradient. Our gradient, it can be either positive 1 or negative 1. That's our gradient. It can be either positive or negative. So this is the equation for the axis of symmetry for a positive gradient. That line. That line. It's given by y equals x plus 1, which means the y-intercept for this line is there at 1. Is there at 1, so it goes like that. Let's find the one with a negative gradient. Remember, gradient is plus or minus. It will be y minus y1 equals negative, our gradient, x minus x1. And then it's substitute. It's y minus 2 equals minus into x minus 1. Y minus 2 will be equal to negative x plus 1, and then we transpose 2. Y will be equal to minus x plus 3, which means the one with the negative gradient will cut this graph. It will cut it there at positive 3. It goes down like that. It goes there. This is y equals negative x plus 3. That's the y-intercept, 3. That's how to find the equation for the axis of symmetry. But there is an easiest way to find that equation. If you are being given the equation of a hyperbola, like here, we were having the equation given by it's h at x. H at x equals negative 2 over x minus 1 plus 2. Right. Let's write this just as a standard form, which is x a over x minus p plus q. Right. For the equation for both positive and negative gradient of the axis of symmetry, you just take the denominator like that. That's what we are going to use. Therefore, that means the equation for the axis of symmetry will be given by x minus p plus q. Remember, the gradient is positive here. Or this is a positive gradient. Positive gradient. For a negative gradient, it's y equals negative of that. X minus p plus q. This one is for a negative gradient. The equation for the axis of symmetry with the positive gradient is given by that. Equation for the axis of symmetry with the negative gradient is given by that. Let's see if the two equations will be the same. Right, we've got this equation and also the one for a negative gradient. Right. For a positive gradient, it's y equals x minus 1 plus 2. This is, you just solve here, it's x minus 1 plus 2, which is equal to y x plus 1. Same as that one. Or for a negative gradient, it's y equals, you just multiply that by negative, we multiply our denominator by negative, it's minus into x minus 1 plus 2. Therefore, our y will be equal to negative x, negative times positive, negative, it will give us positive 1 plus 2. Therefore, our y will be equal to negative x plus 3. So it's one the same thing. But this one is simpler, but you can use any to find the equation for the axis of symmetry. Right, another thing. If you are to shift the graph for instance, you have y equals 3 over x minus 1 plus 3, like that. If you are to shift this graph 2 units up or 2 units down, let's say 2 units down, and 1 unit to the left. One unit to the left. Let's see. Let's say it will form the function of g. Right. It will be g at x equals 3 over. We are shifting this 1 unit left. From positive 1, 0, negative 1. If you are to shift 1 unit to the left from positive 1, because here x is equal to 1 here. So you are shifting from positive 1 unit to the left, it will be 0. Therefore, this means that it's x minus 1 to have 0, it's plus 1. Plus 3, 2 units down. 2 units down from positive 3. Three, 2, 1, 0. We are moving from positive 3, 2 units down. It's 1, 2, which means we need to have 2. Let's shift. 2 units down. We are going down from positive 3. That's minus 2. Our new equation now will be looking like 3 over negative 1 plus 1 is 0. Therefore, it's 3 over x. 3 minus 2, that is 1. That's how our equation will be looking like. If you are shifting to the right, you subtract, you write minus. If you are going to the left, it's plus. Upward, it's plus. Downward, it's minus. Right. For the reflection, it's one the same thing, okay? If you are to reflect about the y-axis, if you are to reflect this about the y-axis, you are to reflect it about the y-axis. You are to reflect about the y-axis. If this comes this side here, it's positive x, it will be negative x, but y is still on, it's still above the x-axis. Y is still above the x-axis, therefore it will remain positive. So if you are to reflect this about the y-axis, x will be affected. That means the image there, if you are to reflect about the y-axis, the reflection about the y-axis. It will affect x, which means this equation, it's y equals negative 2 over, you just multiply x by negative, it's minus x minus 1 plus 2. Everything will be as it is. The only thing that you are going to do, you multiply x by negative as you did there. This is the image of that after reflection about the y-axis. If you are to reflect about the x-axis now, you are to reflect about the x-axis. We've got x here, we've got y there. When we reflect this, it will be like that. But now, this is negative y. When you reflect about the x-axis, y is affected. In other words, you just multiply y by negative. Let's reflect this again to form the function of f. F at x will be equal to negative h at x. Therefore, our f at x will be negative of that, we open the brackets, it's minus 2 over x minus 1 plus 2. F at x will be equal to negative by negative, it's positive, so it's 2 over, our fraction is 2 over x minus 1. Negative times positive, it's negative. That's how our new equation will be looking like. If you are reflecting about the x-axis, y is affected. Reflection about the y-axis, x is affected. Reflection about the x-axis, y is affected. Right, let's stop there with a hyperbolic function.